My name is James, and I will be your host for today's webinar. Welcome to Designing OT Networks for IT OT Convergence. Joining us today are two speakers from Moxa. First, we have Felipe Costa. He is a certified ISA and EC Council instructor with more than 30 professional certifications and a master's degree in industrial cybersecurity. He brings nearly 20 years of experience delivering mission-critical cybersecurity solutions globally. And next, we have Mike Werning. Mike brings over 30 years of expertise in industrial networking and embedded computing, software, and systems. He offers consultation for customers, designing industrial automation systems, and delivers training for industry professionals. Let's go over some housekeeping items before we jump into our presentation. This webinar is going to be 60 minutes, including some time for questions at the end. If you would like to submit questions for our speakers, please use that Q&A function in Zoom. You will also see the occasional poll question pop up on your screen. We encourage you to participate in those. The recording will be shared so that you can go back and watch the webinar on demand. And there will also be a survey after the webinar. We appreciate your feedback on the presentation. And with that in mind, I will go ahead and pass it off to Felipe to kick off our webinar. Felipe.
Thank you, James. Hi, Mike. Hello, everyone. Welcome to our webinar. Today, we're planning to give like three sections about different topics related to networking. We will start basically talking about the resilient networking and explain why that's important. And later, we're going to break down in three different aspects of our resilient networking: safety, reliability, and performance. After, towards the end, we're going to bring some new technology trends that we are seeing different customers bring to discussion, and also sharing our view in how we can apply these new technologies. With that being said, let's jump in and let's start just with a frame about what we're going to cover, right? Basically, let me use my pointer right here. Usually, all this transformation, digitalization, many other things that we are seeing affects directly the networking. But interesting enough, we have been seeing different conversations happening about the OT networking. On one side, we see basically cybersecurity, that if you have been following our webinars, we have been discussing a lot about this and how we can enhance security. But usually, it's just like confidentiality, integrity, and availability conversation, right? Talking about cybersecurity aspect of the networking. On the other hand, we have a very few people talking about it, but usually it's a separate conversation about safety, reliability, and performance. So interesting enough, we have been seeing a lot of organizations, including Moxa and the Department of Energy, talking about, hey, I don't believe that is really the right way to do it. We should be embracing both domains, the cybersecurity and the performance or the OT side of the equation on the same conversation. Usually we see a lot of silos, right? But definitely this is not the right way to approach to have a really resilient network. So this is basically the frame for what we're going to present for now on, that we should embrace the cybersecurity and all the things that are going to enhance the performance on the same conversation, on the same design. And towards the end, Mike, we're going to show an example of a topology that embraces basically these two concepts at the same time. All right. So before we actually start to explain, I would love to understand better what are the challenges that you guys are facing right now. So probably we're gonna see right now. I'm gonna ask it to our team to bring the options. Which initiative is your organization most concerned about right now? So definitely concern, most concern will be one. You may have different, let's say, things happening right now, but if you can, just choose the most important one in your perspective, and we're gonna share the results in a second. All right, we have a couple people working with compliance and cybersecurity. The vast majority so far working with cybersecurity segmentation, secure access, and threat exposure reduction. That's great. And we have a few people working with reliability, right? Like how improve and minimize communication failures, and etc. All right, so let's go ahead. We are sharing the results with you. So many of you are working primarily with cybersecurity segmentation, secure access, and threat exposure reduction, and that's absolutely great. And the second position, compliance, that is kind of related, and the third would be reliability. Thank you. That's definitely helpful, and we're going to see that definitely the market is treating these topics as different things or different initiatives, and hopefully at the end we're going to give enough arguments, right, to make sure that you guys actually combine these two different conversations on the same one, so everybody going to win with that cybersecurity and safety. All right, so let's jump right now and how we want to structure. If you have been or if you joined the last webinar, I kind of shared this table there as well, but with the cybersecurity perspective. So if you can kind of simplify the chart from DOE, Department of Energy, that I opened this webinar, you can say that basically we have two major domains. One is kind of ITOT related, Convergence, and all the initiatives that kind of close the gap or increase the communication between these two domains, the IT and the OT. And far on the right, you're going to have basically the pure automation OT that is standing for operational technology domain. And usually we treat the market treats these domains as two different things. And again, right, the idea is actually combine to make sure you have a very smooth strategy and safety and security communicating properly. And this is definitely the goal that we're expecting to our customers. And the market is kind of pushing that direction too. So if you hear anything about segmentation, confidentiality, detection, monitoring, response, all of that is related to the cyber aspect of it. It's really important, but not necessarily connected to the other part that is safety, reliability, and performance. And this is where exactly we have a huge gap right now, and hopefully the webinar is going to help to address a little bit in how we can connect these two different domains. All right, I'm going to start with the first pillar, that is safety. So if you have been working for a long time in automation or operation technology, should be no brain because basically this is the foundation of the automation, right? And to kind of illustrate for those who are not familiar with, uh, it varies basically on the market or the application you are. So we have here represented basically transportation, oil and gas, rail, and factory automation, and all of them they're gonna have different certifications and protocols. And why that's helpful? It's helpful because each segment or each vertical, you're gonna have a specific protocols needs, a specific environment conditions that are gonna demand that the product is gonna resist in a different variations. If, as for example, oil and gas, you're gonna have a hazard environment that where the device should have very specific conditions or support specific conditions to perform well. Otherwise, you can compromise the safety of the application. And the same applies for all the other verticals. The other thing is temperature. Obviously, in US, you have a huge variation of the temperature. Low temperatures, high temperatures, states that you definitely can reach over 100 Fahrenheit and so on. So definitely the device should be able to operate. Even with the own dissipation, right? The electronic itself should be able to operate uh, without any issues with a high temperature or low temperature as well. So this is definitely part of the design. When we say that a product is an industrial product, this is one of the factors that we consider that were considered in the design, and the product is designed to work under these circumstances or environment conditions. And absolutely translated and many other things. So the components are different. The dissipation, all the calculations that we do, obviously, are considering which market you are deploying this product, what are the conditions that are the suitable in that specific vertical, and eventually how we can enhance and make sure that the performance will not be compromised. So if you put all this together, you're going to be able to provide a redundant and resilient communication, because definitely we have the hardware part of the equation plus the communication that overlays, right, the hardware that it basically pass through the hardware. So definitely, when we think about a safety condition in industrial environment, we are basically saying we need to have this combination happening of a hardware design for that condition plus a protocol design for that condition. And this is basically what we have been doing in our 35 plus years of communication that Moxa has. So this is what we call, and the definition comes from CISA, the Department from the Government that oversees all the industrial mission critical applications. That any application that can compromise the country, right? If it is compromised, it's considered a mission critical application, and this is where Moxa lives. We definitely design our products to live in any of these verticals. All right, let's break down a little bit more what we mean with safety. So definitely any mission critical, nobody can actually afford and say, hey, yeah, it's fine, I don't have water today, or my traffic lights have been going down, or oil and gas. So it's non-negotiable. So definitely every time that I have a mission critical application, we have a condition where the equipment should be designed for that, and you have no other option other than just keep working and provide reliability. So this is the type of mindset that Moxa has, and basically we provide to our customers. One way to translate and make sure that we are delivering what is expected, basically is the certification. Certification helps us to guarantee, okay, the product has everything that are expected for that specific vertical. And consider, for example, oil and gas, we have a tax class 1 division 2 that is a very common certification. For energy applications, we have EC 62050 that has both protocol and hardware requirements. So definitely, when we develop a product to be performed to perform under 62052, we are combining both hardware and protocol, and so on and so forth. So definitely, certification is a very good start. And if you are operating in a specific vertical, most likely you already know which certifications you need. Not part of the conversation today, but definitely cybersecurity is another huge one that we are seeing more and more applications come locally, domestically here in the US, but also globally. And we're going to see more and more of that. But here the conversation is more about the safety aspect, like we're saying, right? And so definitely certifications are not just check boxes. They actually help us to guarantee that all the requirements that are necessary to perform safely, they are indeed deployed on the device. All right, just a little quick, it's a little bit more like a new technology. We will cover a little bit more towards the end. We do have Ethernet APL. That is a kind of a very interesting new technology per se, because actually the idea is one of the higher costs that we have in our retrofit is cabling. So how actually we can leverage in these very old infrastructures the cabling that is already there, and how we can make sure we can take the most of it. I can transmit more information and transmit more data. That is kind of a dream, right? But definitely, indeed, this is what Ethernet APL does. It uses the same infrastructure, the two wire that exists in many of the sensory and lower levels of automation in hazardous applications. And now with a new protocol over the same media, you can transmit way more data. So definitely, if something that you guys are interested, it's a segment that you guys are looking for, reach out for us. That we definitely have more information to share with you. Making this final link between safety and security, definitely they are 100% connected. You'll not extend too much because all the other webinars we had are 100% related to security, but definitely they are kind of connected, right? Or 100% connected, they're saying. So we have a couple of ways that cybersecurity can help in the safety, and we are seeing a lot of supply chain compromising. So definitely, if you can minimize these gaps on your supply chain, you're going to be helpful for everybody. So definitely one of the ways that you can kind of filter your supply chain is through certifications. Like we explained for safety, the same applies to security. And one certification we call secure development life cycle. So already exists certifications that can testify that a specific manufacturer like Moxa has all the requirements to provide products, development, retirement of the product, and maintain the product in the market. And we also have the product certification that guarantees that all the security features needed by now are already embedded on the device. So kind of this combination helps to minimize the attack surface that can be exploited. And ultimately, I do believe that if you enhance your security, you are actually enhance your performance and your safety because you are avoiding a bad actor to explore and do some things with your system that you don't want to, right? And we have many other ways that we can help with these certifications. But again, more than glad to help you guys if you need more information on how we connect safety and security. Last comment over here in this slide, one I really like it is also that is right here. That is how we can make it difficult, right, to compromise and tampering, to tamper the firmware itself. We see a lot of attacks that kind of tamper the firmware. So when the device restarts or tries to access the firmware, you're going to do some things that are not intended to. So the fact that you have these tools that can avoid this type of tampering is extremely important. But moving forward, last slide, kind of connecting cybersecurity with safety. You probably saw this slide a couple of times already, but it's important to emphasize that it's still more than 75% of the industry in the US is still having challenges in deploying segmentation. And I'm glad that a lot of you guys that are joining our conversation today are exactly doing that job because definitely this is the first layer of recommendation when we talk about enhancing the security, safety, and performance of your network. Make sure you have a best or a second layer of segmentation, avoiding easy for malwares or hacker move laterally on your network. We have a couple of other options based on the size of the network, but I just want to make sure that you guys are aligned here. When we talk about cybersecurity and safety connected, we are still saying that you need to have segmentations to properly provide this layer of defense in that perspective. But now I would like to invite Mike, and he's going to help us to explain a little bit the another leg or pillar about resilient network that is reliability. Mike, the floor is yours.
Thanks, Felipe. Appreciate it. Good job on that first section. In this section, we're going to talk about reliability a bit. And reliability in OT networks is not just a single feature. It's the result of a layered approach. So things like network redundancy, robust product design, fault recovery, and then proactive maintenance and monitoring all need to come into play to make reliability. So if we look at network reliability, when we speak of network reliability, it's really one of the key requirements. So it's achieved by providing alternative network paths in the network and then managing those network paths with a protocol. So for example, if in this drawing here we see a turbo ring, a ring of switches, if one of those links were to go down, we obviously want the network to recover from that situation, and an alternate path must immediately become available. Okay, so there's several protocols which can be selected depending on what your application needs could be. So, and the time that it takes to recover will vary based on which one of these options you choose. For example, you see Turbo Ring and Turbo Chain here. These are some Moxa solutions that give you very high speed recovery time. So as low as 20 milliseconds for fast Ethernet. Um, Now, the MRP and spanning tree, those are, industry standards. However, the recovery time is much longer. So the application requirements will determine the need for these high-speed recovery options, really, to avoid communication faults for PLC communications. So if you imagine you have a PLC on the network and it's getting some I/O and it expects to get I/O every 50 milliseconds, for example, the system could COM fault if it loses, as few as 4 packets, right? So 4 heartbeats. So that means that the network has to recover in under 200 milliseconds. So that it's those kinds of things that drive the need for, the more specialized recovery mechanisms in the network. So, reliability and performance, really. So, to kind of expand on the Moxa, unique options and value proposition as we offer these two turbo chain and turbo ring. You can see at the top drawing here, turbo ring is typically used for a network backbone. It's very expandable, it's very scalable, and it scales up to 250 switches in a single ring and still maintains that, 20 to 50 millisecond recovery time. And it's very simple to program for OT engineers as well, which is also key. And we'll get into that a little bit more, later. Now, Turbo Chain allows you to expand on these networks and to really join off of a Turbo Ring or even a spanning tree network and still achieve a high-speed recovery. And because the chains don't form complete rings by themselves, there can be an enormous cabling cost savings, especially for wide area networks that would be an outdoor installation. So think of like a battery energy storage system, a wind farm, or those kinds of maybe solar, even solar, where you would have to trench to bury fiber optic cable or something like that. So it can be a big cost savings as well. And then, yeah, just the interoperability. The Turbo Chain can, expand off all kinds of different network protocols, including the spanning tree networks. So, robust product design is key as well for reliability. In industrial applications, products really need to be designed from the ground up to meet the needs of the industrial environments that Felipe mentioned earlier. But unlike commercial designs, which might be just ruggedized enough for industrial applications, the Moxa products are designed from the ground up with ruggedness in mind. And you can see this in the drawing here, where you can see the sort of the cross section of an inside of one of the switches. Minimize the number of circuit boards, um, minimize the number of connectors before board stacks. This results in lower failure rates and lower energy consumption. And then, from design through testing, the products are going to go into very rigorous industrial designs. And quite often they're in sealed enclosures where there is no airflow at all. So in our testing methodology, we do no airflow testing to ensure stable operation under, high temperature and harsh temperature conditions. So in all of the products will undergo a burn-in when they come off the manufacturing line to eliminate any sort of out-of-box failures that might make it to your, dock themselves. So fault recovery is another key aspect that we have to look at. So, faults are inevitable in networking. Many industrial networks rely on PoE devices like IP cameras or wireless access points in the network. And one of the common things is device lockups. So, and this can be very costly. So if you imagine you have cameras at an intersection or remote monitoring, if one of those devices locks up, you certainly don't want to have to deploy somebody out to that site to recover it. And one of the things that we, put in our PoE designs is we call it smart PoE. And this is a way for the switch to detect an unresponsive device and then, automatically reset power and restore operation. So this translates to lower maintenance costs and improve uptime directly. And it also with that, the device can, alert to the network management system that this has occurred. So, the from proactive maintenance point of view, you can keep your eye on maybe a problematic part of the network, which, maybe needs attention later on down the road. So, and another failure mode is fiber. So fiber is widely used in industrial networks, but fiber can degrade over time. Issues like dirty connectors from, dirty environments. Lots of industrial environments are, full of dust and grime and whatnot. Bending can occur. Junction boxes can be opened. Cables can be pulled. And just overall aging can impact signal quality long before a complete failure occurs. So, we build in features like Fiber Check, which can monitor optical signal levels, provide early warnings when degradations detected. So, this allows for proactive maintenance where, you can address this before there's a complete shutdown, rather than reactive troubleshooting. The link is down, now we've got to do something about it. So basically, the result is improved reliability, faster issue resolution. Um, in addition, if you're using Moxa network software, network management software can alert if packet error rates on links exceed a threshold and give advance notice of degraded service.
All right. Appreciate
Great.
Mike. Let's move to the next section about a resilient network that we're going to talk about performance, right? So the first way to actually enhance your performance is actually seeing what's happening on a network. So visibility, it's a huge buzzword, I know, but it's really important. So we have been talking about visibility on cybersecurity aspect, but actually it's really important. And I have been talking to many customers where their issues are not necessarily cyber attack, but also the fact that they don't know what's happening on their network. So they have a lot of broadcasts, multicasts happening, and this is indeed actually jeopardizing the communication, creating incidents and bringing down the network. So that being said, definitely the fact that you have a tool like MX1 or any other the software that Moxa provides that can help you visualize better your network is really important. I just brought one example to connect perfectly with the concept that we are talking about availability. That is the track view. That actually you can see the utilization of or usage of the specific nodes of our network. So now we can start to see, hey, here I have a bottleneck and I need to do something about this, or I need to do a segmentation. Can be logically to minimize the broadcast, or even the physical segmentation to help me increase the cybersecurity. And with that, I can help minimize the broadcast and multicast domains. So this is one way to look at it, but also sometimes you have been using a network for a long time and you don't know that actually this network is almost 100% out. They are over utilized. So you definitely need to expand to increase the bandwidth. So this is another way to look and use these preventive tools to visualize not just the pattern, but also where we eventually need to start to work in some upgrades. So with that, you keep this smooth performance of the network. So definitely traffic is one of the most important things that you should understand. But the fact that you understand, you can better plan and keep the performance of your network. And I'd like to invite again Mike to talk about the time synchronization right now and how it can help with the performance of the network.
Thanks, Felipe. So this is time synchronization. It's critical in many industrial applications. So, think of applications like in substation automation, factory automation, where motion control, coordinated machine control is very important. We use a feature called 1588 Precision Time Protocol, and this allows sub-microsecond synchronization across the network. And to kind of explain this, if you look at the table up above, you can see some, other technologies like simple network time protocol and NTP network time protocol. And you can see that, the accuracy of those clocks is somewhere between, a millisecond, and it can be, even up to 100 milliseconds, depending on the network type. And compare that to precision time protocol in less than 1 microsecond resolution for the clock. So it's really very deterministic, very accurate clocking for these kinds of applications. So, at the bottom, to kind of illustrate this, you've got a master clock in the network. They call it the Grand Master, and it's sending out the time reference. This time reference has to cross, oftentimes many network switches, network hops, and whatnot. And there can be delays, transmission delays, residence time delays in each one of those network devices, which by the time the clock gets to the slave device, it's now late, so or off by some error amount. And what precision time protocol does is through time stamping, it can remove those delays such that the time when it's received by the slave clock is as accurate as when it was sent within a microsecond. So just a key feature for these sort of cordon machine control and substation automation. So interoperability is another one of these things where we just, it's rare that you're ever going to run into a single vendor environment. And so interoperability is a key. And we've already, talked a little bit about some interoperability from the redundancy protocols, spanning tree, MRP, HSR, turbo ring, and turbo chain. So, um, these being able to support a lot of different protocols in, one managed device, allows for more seamless integration into existing designs, existing infrastructure. So if you're trying to modernize the network by, upgrading the network equipment for cybersecurity and other, reasons, this, interoperability is just going to be key. So whether it's spanning tree, as you can see in the bottom here, where you sort of have this mesh design, the same switches can be used there as in a turbo ring design, or even in a mixed protocol design, where you might have spanning tree in the core, and then you want fast recovery on the edge, and you could use something like turbo chain to bolt off of that spanning tree, or even a turbo ring core. So interface compatibility is also key as well. So, we see it every day. Many facilities have significant investment in fiber infrastructure, and they want to modernize, but they don't want the added cost of, replacing all the infrastructure in the manufacturing cells and whatnot. So, Moxa doesn't just support the SFP with the newer, LC style connections, but we also support legacy fiber connections like the ST and the SC style. So, this allows customers to modernize network equipment without replacing all the fiber cabling. So, the result is a faster, more cost-effective upgrade path for, brownfields. So at the bottom of the screen, you can see sort of an example of one of these. This is our EDS 4000 series, a DIN rail switch where there are over 68 different models to accommodate different I/O, requirements in existing brownfield applications. So, part of building a reliable network is to being able to manage it and maintain it over time. And we realize that OT engineers aren't experts in or they are experts in automation. They may not be experts in necessarily in networking. So we try to make it very easy to program devices by providing both a fully functional user interface, where everything that can be programmed can be done graphically, as well as providing a very familiar command line interface for the IT side of the house. So oftentimes, equipment is going to be maintained by IT, and they're going to want to, automate tasks, for example, or be able to use their familiar, command line. So we provide both of those interfaces in the networking equipment to accommodate both of those needs. In addition, managing the network and monitoring it through network management software. Here you can see an example of, Mox's network management software called MXView 1. Being able to see, visually when a link is up or down, and being able to monitor events as they're sent by network devices in a central location is key. But we're just not locked in to, Moxa software. We're compatible with third parties that also use SNMP for management as well. So being able to maintain the network's key for reliable operation of the system.
Thank you, Mike. And I appreciate it. Definitely, you walk us through all the different ways that you can enhance the communication, right? In different protocols and interface.
Mhm.
Definitely on the new technologies, we may talk about so many different technologies that we are bringing right now in the near future. Intercat is one of them, but definitely to the context that we are here today, I would like to talk more about two different technologies that are we already have products for a long time on these technologies, but they are extremely important for the future generation of the networking. The first one, probably you already heard about TSN, that is time sensitive network. That is basically how we envision the future. You're going to have this multi-purpose type of network where you have so many protocols being transmitted on the same media that is kind of difficult, right? You manage how you can make sure that the critical information is going to reach the destination earlier than no critical basically application. So this is exactly why the time TSN, the time sensitive networking, was designed for. Basically, it's designed with the time synchronization that Mike have explained us one of the concepts and how it works. And through the time synchronization, it can guarantee that the specifically critical information is going to reach the destination in a timely manner and in a very precise way. And this is how we see that the network is going to converge in the future. And obviously, we're going to talk about cybersecurity and how we should keep protecting data and how we can enhance through the protocol as well the cybersecurity. So definitely still huge, and I don't see any future where cybersecurity will not be part of the conversation. So everything that we're going to bring as a future conversation, obviously, we're going to bring cybersecurity as well. And here, just to make a connection, we talked on the first slides about APL. That is the protocol that it can use leverage the old two-wire infrastructure to transmit more data. And another protocol that it basically does the same thing, and we're going to explain a little bit more in the next slide, is SP. So these two protocols, they are bringing basically Ethernet to the lower level of Purdue model. For those who are familiar with, basically the layers 0 and 1, they're the very, very low automation layer. They are basically bringing Ethernet right there and make sure that the communication and all the advantages that we have with Ethernet, we can leverage as well in that specific layer. So this is basically how we are anticipating the usage of TSN, the combination of this protocol with many others. The last protocol that I'd like to highlight here is the single pair Ethernet. Like I explained in the first slide with APL, it uses the same principle. You can leverage the very old infrastructure with the two wire that many sensors and the old infrastructure utilize, and just change the protocol and obviously the devices on the network that are compatible with single pair. Now you can increase dramatically the bandwidth on the same infrastructure. And definitely, this is one of the pushes that we are seeing. All sensors, AI, many other initiatives, they are demanding way more data. So, in order to do better decisions and enhance your performance, you need to have a better visibility. And one way to do this is actually capture more data. Obviously, another conversation, all this management of this information and how we're going to transmit and where it's 100% related to cybersecurity. So we are not just saying that you should be doing in just the way that we want to do, but definitely following the best practice of security. But we are definitely highlight here that we have way more possibilities now to leverage data and increase our performance while keeping the cybersecurity as a foundation as well. All right, now I'd like to invite again Mike to walk us through one example of application that can combine all the concepts that basically we navigated through these couple of minutes together. Hey, Mike,
Great. Thank
walk
you,
us here.
Felipe. So this is pretty much the big picture, right? So you can see some, application areas at the bottom here in different areas, and you can really see how all this technology can fit together to provide, high availability in control systems. So, if we look at the bottom up, the edge applications can achieve reliability through, the use of the industrial rated devices that we just spoke about in the presentation. And those devices can be networked in a high availability ring, such as in Turbo Ring, for example. And those, ring uplinks can be secured through the use of industrial next generation firewalls, basically connecting them to the plant network and adding security zones to prevent the spread of malware. Products like the Moxa EDR series can be used for those kinds of purposes. And then the plant network can also be designed for high availability using protocols such as Turbo Ring. And in addition, a dedicated ring can be added and used to mirror packets for cybersecurity monitoring applications. So you can see, all the packets that are flowing through the main plant can be, mirrored over that second ring and sent to a packet analyzer system. And then, that can help with the security, posture of the entire plant or that application. And then finally, network management through the use of MXView 1 or a network management system and MX security that can, push the signature files to the deep packet inspection engines, the EDR 9010s, for example. So to kind of summarize, the drawing, it's, device reliability at the edge, reliable networking through the use of, high-speed networking protocols like Turbo Ring, Turbo Chain, security through the use of the firewall technology, and then plant redundancy through the use of redundancy in rings and cybersecurity redundancy through rings, and network management system management for monitoring and maintenance of the ongoing operations. So with that, back to you, Felipe.
Perfect. Thank you, Mike. I appreciate it. That's great to see all these concepts, right, really working together. Obviously, we mentioned during the conversation a couple of products, but our portfolio is really vast. We have thousands of products. We are obviously talking this webinar about networking, that is basically the spine, the foundation of the data. So we are obviously emphasizing more the networking aspect of it in the firewall. But Moxa does way more than that. Specific for networking, you can scan here the QR code, and we're going to be directed to our landing page with more information about how we put together a networking and cybersecurity and deliver these basically very concise and communicated pretty well safety and cybersecurity on our projects. And here are a couple of products that we consider our new generation that brings all the software and capabilities, that brings all these protocols that keeps the network safe and secure, and also for the future generation that can keep us allowing us actually bring more features and provide security through the product life cycle. The second thing that I'd like to share with you is here, if you have interest to receive our experts and have conversations, we are doing some solution days that are basically, we have different topics. Cybersecurity obviously is one of them. And you have a lot of options about cybersecurity, but I also have about safety and exactly what this webinar is about and how we can help our customers to combine safety and cybersecurity on the same design and make sure that these two important domains, they are being accomplished on the design. So definitely have a webinar and a solution day that can help you accomplish this. And if you have interest, you can scan this QR code, and you'll be directed to another landing page where you can fill out your data, and our team will be able to contact you. So with that being said, I would like to go to the last section of our webinar today, and you're gonna be receiving one question. If you'd like any of us and our team to contact you to help you in any project that you may be working right now, many of you guys shared that you are working projects, so we are more than glad to help you during this journey. So if it's you, you want to be part of this and help, let Moxa help you, definitely check with AS and they'll be more than glad to contact you and align the details. If it's cybersecurity related, most likely I would love to connect with you and better understand your challenge, but I definitely will have a whole team behind to support you in many other initiatives that you maybe you're working on. With that being said, I would like to make our closing and recap a little bit a few aspects of the things that we cover. So the first one, resilient by design. So I feel that this is really a lot of the automation or OT domain that we do and we have been done for a long time, and how we combine redundancy and segmentation. Right, this is the challenge right now. So historically, we have been doing pretty well in doing all these ring topologies, NRP, many others, but rarely we connect this concept with segmentation. So this is our next and current challenge. The second I summarize here is safety, security, and security, safety, and safety, security, because actually we cannot do design considering two different domains. And again, we should combine those two. And a couple of examples that we walked through, the device should be industrial device, and we have a couple of ways to certify that. I have secured by design, so I need to make sure that when I'm specifying, I'm considering the best and latest and greatest in terms of cybersecurity to make sure that through the life cycle of my project, I would have technology that can observe these new features that will be necessary during the future. And as far as certifications as well. And ultimately, in the third topic, we talk a little bit about fast recovery and hooded hardware that basically delivers, right, this combination of safety and security connected through the design. Ultimately, we talked about performance aware. So a lot of the industry is still struggling and how visualize information. And if you want to increase your performance, vis- visibility is the key because actually it's going to help you understand the pattern of the communication. And on the other hand, you're also going to start to see with other tools also eventually some vulnerabilities that you may have and things that you need to address. Because ultimately, I made a point that if you have a cybersecurity breach or an incident, actually this is definitely going to jeopardize your performance. So safety and cybersecurity, they are connected. You just can't have two separate conversations about these two topics. And with that, I would like to open right now for a Q&A section towards the end. And James, I would like to invite you to take over from now. Thank you.
Absolutely. Great job, you guys. Thank you so much for all that information. As Felipe said, we're opening it up for Q&A right now. So go ahead and if you guys have any questions, use that Q&A function in Zoom, and then we will try to get to it. I'll go ahead and start with one that we have right here. The first question we have is in the network reliability section that you mentioned turbo chain. Can you explain how it interfaces with other network protocols? Turbo chain and how it interfaces with other network protocols.
I can take that one, James. So Turbo Chain, it interoperates with the other network protocols because it knows how to send certain commands to those other protocols and let them know when there's been a topology change, for example. So with Turbo Chain, you can use it with a spanning tree network, and when there's a change to the topology in the Turbo Chain, it can send the topology change to the spanning tree network to let it know that hey, things have changed, and you need to do things like flush your MAC table and do things like all of the spanning tree things that it needs to know about and do in order to recover as well. So same thing with Turbo Ring is that when there's a turbo ring and turbo chain's connected to it, it knows how to tell turbo ring that the same kind of thing has happened and such that it can react in a timely manner and do all those same kind of housekeeping chores to make sure that you've got the high speed recovery in your design.
All right, thanks, Mike. Since we're on the topic, I see another one about turbo ring and chain. So let me just ask this one. With turbo ring and chain, why is fast Ethernet recovery faster than gigabit? Is that an error?
Yeah, that's a common question, actually. So people think, well, gigabit is faster, so therefore it should recover faster, right? So it's a common thing, and it actually goes back to the IEEE spec for the PHY, and the way the PHY performance is in fast Ethernet, which is 100 megabit Ethernet versus gigabit Ethernet. And so that's why you see the discrepancy, and we'll quote that differently. So 100 megabit Ethernet, can recover in the under 20 milliseconds, and then for gigabit, it happens to be 50 milliseconds. So that's without getting all in the details of the way the PHY works, but that's the crux of the difference right there.
Gotcha. Okay, let's see. Another one here that just came in. You mentioned bringing internet down to the I/O level. Can you explain a little bit more about this?
Sure. I believe I can take that one. So basically, if you see the Purdue model, nowadays you have a lot of protocols that are serial or old generation in this lower level. So when we talk about the APL or SP, actually instead to be a serial device per se or a serial protocol, actually you're going to be transmitting Ethernet protocol over it. So the same thing that happened with DeviceNet or Profibus, that they were kind of encapsulated over TCP/IP, kind of is the same thing that's happening with the IO level with SP and APL. So this is a kind of the last frontier, if you will, that Ethernet is going there. Obviously, uh, we every time that we talk about Ethernet, we have cybersecurity concerns. But if the story proves something, Ethernet always won, right? So definitely our questions and our designs, we are trying to think in the best way to deploy in that level, but considering security concerns as well. There,
Thanks, Felipe.
sure.
Here's another one. So for mission critical OT networks, how should we decide between standard redundancy protocols like RSTP, MRP, and faster options like Turbo Ring or Turbo Chain? Let me
Yeah,
know if you
I
need
can
me
take
to.
that one. Yeah,
Yeah.
no, I got it. Mike, please feel free to chime in here as well. I feel that basically two things, right? You need to consider if you have like a primarily one manufactured design. So if you just have Moxa, for example, in that particular network, and the type of resilience you want. So Mike kind of explain the different ways that you can do it with rings or stars, etc. So if right, it's just Moxa and you are okay on doing a ring, obviously you have a lot of advantage because the time of recovery is way faster than many other protocols. So this is pretty much about the options you have in your hand. So in the other hand, if you just have a mixed manufacturing network, it's hard to leverage, or you can even leverage tubularine. So you definitely need to move forward with the MRP or RCP and so on and so forth. So I believe that is a matter if you have the ability to choose. Mike pretty much explained the advantages on the fast recovery, predictability, and many other things that we can offer with our network. But Mike, feel free to explain or add anything.
Yeah, I think I mentioned in the presentation that the application needs drive a lot of that. So
Right,
if I did an example where if the application will COM fault in 200 milliseconds, it means you need to do something in under 200 milliseconds. The network has to
right,
recover. So a lot of times those kinds of requirements will drive that technology, but a very valid point, Felipe. If interoperability and lots of vendor interoperability in the network, you may have to use, a spanning tree kind of design, or depends. Maybe you can use PRP or something like that, which is zero packet loss kind of technology. There's a cost, of course, that goes with that reliability. but the application is going to determine it a lot of times for you.
Great.
Great. Thanks, guys. One more here. What tools or features can help maintenance teams detect problems earlier, such as fiber degradation, packet errors, or locked up PoE devices?
Yeah, I believe I can mention some, but definitely I believe it's more in our section. Like, but definitely you mentioned about fiber check, smart PoE. Definitely, these are the ones that I believe come to my mind that you also covered during the conversation that can help you anticipate and troubleshoot, right? When you have a challenge on communication, you can try to find the root cause and fix it.
Yeah,
Okay.
Do you
certainly
have
network
anyone?
management as well. Having
They're good one.
watching the network, having something that's collecting the events like a network manager and MX View 1, that when something happens, it immediately is getting a trap. Somebody's getting alerted that there's been an event, and they can look at, what's the mediation for this, and then collect any sort of, trail of breadcrumbs that's now in the NMS because, events were received by it. So proactive maintenance, proactive monitoring of the network is essential going forward. Being able to visualize the link up down state for sure, and that's why we have MXV1, and other vendors have their version of that. But it's just an essential part of owning and maintaining an industrial control system.
I love it that actually I answer based on your section and you answer this question based on my section. So I love that, right?
I think that's a good segue into this other question that I'm seeing here about management. So it says many OT networks are multi-vendor. How does Moxa support interoperability while still enabling advanced segmentation and centralized management?
That's a hard one. I definitely would use take from what Mike left, basically the NX1. One of the things that he mentioned, if it's an NSMP device, we will be able to see that device. Obviously, it's limited what we can see, but actually, at least we can see on the design, and you'll be able to see where is it connected and so on and so forth. But if I know that is not 100% maybe the question, but in the cybersecurity perspective, the firewalls, the deep inspection that Mike explained, and many other features, they are not vendor aware or they are not restricted right to the vendor. So we are able to inspect the information. Doesn't matter who is the manufacturer of the device because actually you're inspecting the traffic itself. So as far as security perspective, doesn't matter if you will the manufacturer. So our solutions are going to work with any because again we are inspecting the traffic. But as far as the visualization and things that we describe, obviously we're going to be able to provide way more with Moxa, but it's still the minimum of visibility to the other manufacturers. I don't know, Mike, you have been deploying a lot of things. What do you think?
Yeah, I think that's on track. I mean, SNMP, obviously, that's a standard. There are some standard MIBs that, all the manufacturers should be implementing. Tools like MXV1 utilize heavily those standard MIBs versus private MIBs that would be in devices. And also syslogs. So all of our security devices can issue syslogs in common event format, which is a common interpretable, event format, basically. So there's a built-in syslogger in MXV1, for example. So you could direct all of the syslogs there and then forward them onto a third-party, analysis system if that's what you
That's
have in
good.
your network as well.
That's great.
Awesome.
Appreciate that, Mike.
Mhm.
All right, guys. I think that's going to be what we have time for today. I just wanted to thank everybody for joining us for this webinar. We'll be sending a follow-up email afterwards with a link to the recording so that you can revisit any of the topics that we covered today. You'll also see a link to a survey that will appear at the end. We appreciate it if you could give us your feedback on how we did. And just lastly, thank you, Felipe and Mike, for sharing your expertise on how to design OT networks for IT/OT convergence. This wraps up our webinar. Thank you everyone for attending, and we hope that you found this information valuable. Have a good one,
Thank you,
everyone.
guys. Take
Great.
care.
Thank you.